Okay, so we're on to final review sheet number 3, I think. Right? I hope so. Yes, thank God. This has a different title above it. Final review sheet number 3, and we're going over number 10. We're starting off with, okay. A statistician was exploring a set of data that showed the mean was 49 and the variance was the 16. Find standard deviation. Standard deviation is the square root of the variance. Always is. The square root of 16 is 4. Next up, a little expected value. Expected value is always the product of these two, okay? So if you're going to win $50, but the probability is 1/4, then expected value for that particular row is 12.5 or 12.5. 100 times 1/5 is 20. 150 times 3/10 is 45. 200 times 2/5 is 80. Add them all up, you get 157.50. So your expected value, should you play the game, is $157.50. Another example, in a board game, players take turns spinning a wheel with 4 spaces and values of 100, 300, 400, or 800. And the probabilities are 4/9, 2/9, 2/9, and 1/9. So if you multiply it out, you get 44.4. I did a little rounding off here. 66.7, 88.9, and 88.9. And altogether, add them up, it's $288.9. Or $288.90 is your expected value there. Order from closest to the mean to furthest from the mean. Well, the closest to the mean there is negative 0.5. Okay, that means it's only a half a standard deviation away. The next one is 0.75, which is 3/4 of a standard deviation away. Then negative 0.95, almost a whole standard deviation away. And then 1.15 z-score, which is a little more than 1 standard deviation away. Number 13. Suppose your stats professor returned your first midterm exam with only a z-score written on it. She also told you the histogram of the scores was approximately normal. How would you interpret each of the following z-scores? 2.2. Oh, you did very good. You were well above the class average. Or you did very well, I should say. You are well above the class average. Negative 0.4. I don't know about that one. You're a little below the class average. 0 means you got the class average. Okay, next up, the test scores for a quantitative reasoning section of the GRE are normally distributed. The mean score is 150 with a standard deviation of 8.75. The test scores for the 4 students are, and this time we only want to know the z-score for 162. So the z-score is always the regular score minus the mean divided by the standard deviation. In this case, it's 12 over 8.75. 12 because 162 is the score and 150 is the average. So subtract, you get 12, and that would be, when you do the division, 1.3714. A little bit of summation work here. Evaluate if x is 4, 7, 9, and 3. Square each of them, because this says to square it and then add 3. 4 squared is 16, 7 squared is 49, 9 squared is 81, 3 squared is 9. Add them all up, you get 155. Then you add the 3 that's at the end here, you get 158. Remember, to add the 3 first, it must be in parentheses. Okay, number 15. X is 1, 2, 3, 4, 5. And this time, because it is in parentheses, you subtract the 5 first. So you get negative 4, negative 3, negative 2, negative 1, 0. Add all those guys up, you get negative 10. And negative 4 times that summation symbol means negative 4 times that negative 10 that you got when you did the summation. So that would be negative 4 times negative 10 is 40. Okay, number 16. The mean undergraduate cost for tuition, fees, room, board, 4-year institution. Find probability sample mean. That's big. So you got a normal curve, you got a sample size, and you've also got a sample mean. So we're talking central limit theorem here, okay? So we're going to go second vars, normal CDF. You go from negative 10 to the 99th for the lower end up until 27,300 because you want to be less than 27,300. The mean is 26,489. And as far as the standard deviation goes, we want the SE here, so it's 3104 divided by the square root of 36. We crunch those numbers, we get 0.9415. That's your probability. Number 17, an IQ test has a mean of 100, a standard deviation of 15. Between what 2 scores do 68% of the scores lie? I've shown you the normal curve on the last 2 videos. I won't on this video. 68% is 1 standard deviation below to 1 standard deviation above. So 1 below, subtract 15, 1 above, add 15. That's 85 to 115. Okay, the time taken to manufacture a certain car at a plant has a normal distribution, Ziva, be quiet, of 28 hours with a standard deviation of 2.5 hours. So you put this in here, quiet, and you get 24 as the low end, 27.5 as the high end. That's the interval you want to test here. 28 is the mean, 2.5 is the standard deviation. You work all of that through, you come out with 0.3659. Notice you don't divide the standard deviation here because it's not a sample mean. This is just the probability of a single thing. And number 19, radar unit measuring speeds on a highway. The speeds are normally distributed with a mean of 90 and a standard deviation of 10. So, normally distributed, probability picking one at random, so we don't need to divide by the square of the sample size. Second bar is normal CDF again, because we're dealing with a normal curve. It tells you that with the words normally distributed. So, let's see, we want the lowest speed to be 100. However high after that, doesn't matter, 10 to the 99th. 90 is the mean, and 10 is the standard deviation. Crunch those numbers, 0.1587.